Hey there, welcome to video number 10. And I'm going to start off with get another silly error on my part. I should have, so first off, so this particular function here, getting the channel value, it brings in a number, comes from the radio of somewhere between 1,000 and 2,000. What it does, it converts 1,500 to 0. It converts 2,000 to 100, and it converts 1,000 to negative 100. That's what this little set of functions in here does. But the more important thing I forgot is that notice the word float here. And every other function we've ever done, it's not returning any value. This is the only function we're going to have that actually returns a value. It returns a float. And that float actually, what it means, it returns a decimal number. And I should have pointed that out and forgot. And one other thing I want to point out is we're going to add one little thing to up here. We're going to add a thank you. Thanks to Marist, M-A-R-I-S-T, Design and Engineering for the driving code. Actually, the original driving code has changed quite a bit, but, design. That's where I got it from a YouTube video that they were actually, it's a video and a text that they were producing. That was a couple of years ago. I got it modified quite a bit, but if you ever go check them out, you'll recognize it. Okay, now we're moving on. We're going to work on the driving function now. The driving function here, this is by far the most complex function. Again, I'm going to just copy it from my other work. And then, let's see, let's put it right under here, I guess. And again, I'm going to take it from my other work for the prime. Whoops, this is the wrong one. That's the prism. Where's the other one? There we go. Okay, the driving function. It's quite long. It doesn't even all fit on one screen, so I'm going to have to mess with that a little bit. Let's get it copied over there first, and I'll talk about it more. There we go. Okay, so this is the whole function, and we're going to have to work on getting it in such a way that you can actually get it typed in. So, first thing it does, these two floats right here, turn and power, it takes the channel values from, this is what gets the values from the radio. So it says get channel value, so it uses this function here to get a number between minus 100 and positive 100. And notice right, this version I have has minus signs in front. Very easily could be positive for you, depending on how your robot is set up. Let's scroll down a little bit. Okay, the next thing it does, so let's see it here now. And again, pause wherever you need to. So the next thing it does, it modifies the two values by those the functions we had up there, which said the speed constant, so that in fact we could change the speed constant, which it's useful later on possibly. And then it actually defines power that's going to go to the A motor and power that's going to go to the B motor. And it's very tricky the way this works. It's amazing. It takes a long time to think your way through it. Pause. Okay, next thing it does is, in order to avoid, in order to kind of have a wiggle room right around 0, it just modifies a little bit. So if it's if it's plus or minus 10, it says, nah, okay, wait, I won't just pretend as if there's nothing moving at all. That's what these two lines say. Next thing it does. Okay, this one says if you're slamming the joysticks back and forth or left and right and really quick and fast, that could potentially mess with the gears and the motors. So what this particular pair of functions does for power A and then for power B, what this does is it says, no, wait a minute, if you're slamming those things back and forth, I'm gonna slow you down a little bit here so it's not quite so fast. You really want these in? Honestly, it's fast enough. It's just protects the motor and the gears and whatnot. And again, pause it to get all this right. You just have to have it right. Include especially all the comments. Okay. Okay, next up is the boundaries. What this does is this functions could conceivably be higher than 100 or lower than minus 100, which would mess with the numbers that are sent to the actual motors that the controller sends to the motors. So this takes care of those boundaries. Make sure it can't go bigger than positive 100 or less than minus 100. That's what these 4 ifs do. And finally, this keeps track of the old power versus the new power, so it can be used to slow down, keep track of information. And then this line right here is the one that actually does the work. This is actually sets the powers to power A, and power B sets the 2 motors. Notice the note out here. You may need to change the plus and minus signs if it's not working right. There's actually several ways to do that. In this particular implementation for my robot, I need a minus sign here. I don't need one there. It could be the other way for you. It just depends on where you have your motors and a lot of little things that make some adjustments. Okay, that's the whole drive function. And I think we're going to stop there because I need you to copy this in. Copy in all the stuff I've told you today, and you should be able to again compile it and run it, and now you should be able to control your robot driving it around. Okay, so we'll see how that goes. We're going to do the next 2 functions here in the next 2 videos. Good luck with that, and hang in there. If it doesn't quite work, that's okay. Honestly, there's a lot of ways things can go wrong between the wiring, the switches, the joysticks, the way the joysticks are set up, and the way the coding is. There's a lot of things that go wrong. If it not quite working right, that's okay. As long as you're working somehow, you're okay. Okay, see you in a bit. Bye.